Alright guys, so in this video we'll create a random integer array generator. This generator will give the user the ability to choose some parameters when this array is created, okay? So the first parameter that he will choose will be the size of that array, okay? The second parameter will be the lowest possible value and the maximum possible value that that a specific element of the array may have, okay? So let's say the smallest value will be A and the greatest value will be B, okay? Also, the user will choose if he wants each element to be unique or not, okay? So unique or not. So if he gives 1, each element will be unique. If he gives a 0, which is going to be the other option, then each element will be, we will not guarantee that each element will be unique, okay? So first of all, let me show you how the rand function works, okay? So a lot of you may know this rand function to create random numbers. So if I were to initialize this, so how you initialize this function is you actually initialize the random number generator, okay? And how you do this is you call asRand, okay, to give a seed to that random generator. And the seed that you will put for that random generator will be time, okay? And you will give for this function time the input 0, okay? So what will this do is get your system's time and input this time as a seed to this random number generator, okay? This random number generator, okay? So you call this initially. You have to call this initially, otherwise your numbers will not be actually random. They will be pseudo-random, okay? So this is pretty much it. So you call asRand, and now you can run this function run. But the thing is, this function will return you a number from 0 to some limit. And to find out what that limit is in your current C++ implementation, you just output rand underscore max, okay? If you output this, you will get the limit. So let's run this and see what is the limit in my machine, okay? So it's finished, and we run this program, and we get 32,767 to be the highest value that we might get, okay? So let's note this down, okay? Let's note this down here, okay? 32,767 maximum value from rand, okay? So we note this down. And we will use this later when we will be creating the random numbers, okay? So first of all, let's read these 3 parameters as the input from the user, okay? So let's declare them using LL. So LL is actually long. I also forgot to mention that I'm including this library, which includes random as well, okay? It includes the random library as well. So you go ahead and you declare these parameters. So let's call this size. Let's call this S actually. A, B, and U, okay? So we ask for the size, give the size of the array, and we read this in S, and then we ask for the smallest and the greatest values, the lowest value, actually just lowest value, okay, and we ask this from the user, and we read in A is going to be the lowest, and afterwards we ask for the highest value, all right, and you read in B, okay, and then we ask if he wants unique values or not, okay, and we read in U. This can be a Boolean array, a Boolean value. Okay, so we have written the parameters that the user wants, and now we're going to go ahead and declare our create our array. Okay, so first of all, what you have to do is to get the difference between the greatest, so B minus A. So you get the difference between these two, and what we will actually do is generate numbers from 0 to diff. Okay, And then what we will generate, we will add to a. So a plus some number between 0 and difference. And this will give you some number between a and b. Okay, so this is pretty much it. So we do a loop, we go from 1 to the size, okay, and we say that the next number is going to be equal to a plus some random number. This function random we will develop afterwards, between 0 and difference, so we just give the maximum, which is difference, okay? And afterwards, we have to check if also this value is unique. So here you have a uniqueness test. And how we will do this is, in this development, I'm going to use a map, okay? I'm using a map because the values that our elements might be very big, so it wouldn't be wise to use an array instead, like use a Boolean array appears, like if the number appears, and have like a lot of elements, like because we have a memory limitation, okay? So the best solution would be to just use a map in this case. We have a memory limitation because for each specific value we have to keep a boolean, okay? But if we use a map and we have like a small array, like not a lot of numbers, but we have high values, like the difference can be very, like 10 to the power of 18, for example, then it's better that we use a map. So you can do this with an array as well, but I'm going to develop this with a map, okay? So map, and we have a boolean for each element. Let's call this MP for map, okay? So we test the uniqueness, so we go and we test this. If when we search for the element in the map, if this doesn't equal to the end of the map, so we found some occurrence of this element, so this element already exists in our array. So what we will do is recalculate it with a different and get a different number, okay? And hopefully get a different number, which is not in our array because it's a random. So this is a randomized algorithm, okay? So let me note this down, randomized solution, because we get random numbers. And what is random is not the accuracy of the algorithm, is the time, the time of the execution, okay? So this might execute for infinite time, like every time our random generator might give us some number that already exists in our array. So this loop here will be repeated over and over again without ending, okay? So this is a Las Vegas solution. That's what you call randomized solutions that have uncertain time of finishing, of ending of the execution. But the result, when this program ends, we know for sure that it's going to be correct, okay? So we calculate the new next, and we actually search for the next again, okay? So once we are out of this loop, we know that next doesn't appear in our array. So we go ahead and we say, what do we call our array? No, we have not declared it, so let's declare this here. So vector of long rand array, this name is rand r, okay? And we say random array dot pushback our number next, okay? And we also put this in the map, okay? Once we use it, we have to put this in the map. So random of next equals to true, okay? Okay, so this is inside our map, this is inside our array. We also have to check that the user picked this to be uniqueness, like you go ahead and you say and uniqueness. We name this u and u. So if u is false, so he doesn't want them to be unique, we're not going to check, we're not going to generate again a new next, okay? And we also put this only when you have u. Like if you have uniqueness, you use your map. Otherwise, there is no need to use the map, okay? So that's pretty much it. That's pretty much the solution. The only thing left to do is to create this random function, okay? like how will we overcome the obstacle of the fact that the maximum number that we get from rand is this 32,767. So how will we overcome this? So we have this here. Let me also develop the loop for outputting the result. So from 1 to the size of the array, okay, we say rand array I is what we will print. Let's print space between each element and an end line at the end. Let's also print out the numbers of the array, okay? So how many numbers will be in the array, okay? So size of rand array, just to make sure we have put the correct number of elements, okay? So this is the output of the array. Let me just comment this as well. Output, okay? Okay, here we output the array. And this is the loop that we created. Now the only thing left is the random function. We have to develop this random function to overcome the obstacle of 32,000, okay? So random, and we have a limit, okay? So initially what you will have is a number. So this name is value, which is going to be what we will return. Let's call rand for this value, okay? Then you repeat for like 10 times. And for each time you do this, you multiply your value by random again, by some random number. So that will give you a greater number. So it's possible you get a greater number than 32,000, okay? And you multiply this, and you modulo this by by the limit. So limit plus 1. So why you do limit plus 1? Because if you modulo this, you will get from 0 to limit. If you modulo with limit plus 1, so the result that you will get will be from 0 to limit. Some might say that if I multiply each time, it is possible I'm not going to get a prime number. Like, let's say that my limit is so big that that the modulo actually does nothing, okay? So if I do this, then I have to do some addition as well. Like you can, like to get prime numbers, you can do some addition as well. Like let's say you get only small random values, okay? And when you multiply them, you're not above the limit at any time. So your modulo does nothing actually. So the trick here is to just use summation. So you can sum some, again, random value. And that way, you know that it is possible you create prime numbers as well. So we cover the possibility of prime numbers as well. And again, of course, you have to modulo. You have to copy this line and modulo, okay? All right. So you have modulo again with the limit. So for sure, your value is between 0 and limit, okay? And you return your value. If you want, you can do this like less times. Like you can do this 6 times. But I say 10 because if you do this like for 10 times, for sure you are going to get above your limit. So it is possible you reach the limit as well. Because if you do not reach the limit, then you give false random numbers. Because you say my limit is 10 to the power of 18, and I never tried, actually, there is no chance I'm actually gonna reach this number just by multiplying my random values, because I do this like for only 2 times, then it's not actually a good random generator, because I leave values outside of the possible results that I might get from this random function, okay? So that's pretty much it. So that's how I will develop random. And let's go ahead and call this, I think. So let's call this program, split this, and call this and see the results that we might get. Okay, so we built this. Perfect. So let's run this. I forgot to flash each line, so we do not have... so here, I say flash. Okay, you copy this array here. Sorry, this line here. And go ahead. You paste it after each message you give to the user. Okay, let's build this again. Okay, so we go here and we run the program. So give the size of the array. So let's say we need 10 numbers. Give the lowest value, minus 23, for example, and the highest value is 10, okay? Unique values, no. Okay, so what did we get here? Did we forget to... yeah, I forgot to go until the size. So you go from 0. Yeah, we have 0 indexing in our array. So you start from 0 to s minus 1. This is no problem because we do not use index here. We just push back. Okay. Here we just push back. So this loop is okay. But this loop should go from 0 to s minus 1. Okay, so let's build this again. Okay, so it built still. So it built. Nice. So give the size of the array 10. Give the lowest value minus 23. Give the highest value 10. And we can have duplicate values. So as you can see, all the values are between minus 23 and 10. We have no duplicate values. Let's use this again. Let's say 20 numbers. Lowest value is 1. The highest value is 5. Of course, we have to have duplicates because otherwise we will have infinite loop. Because if we ask for, we have only 5 unique values and we ask for 20 values. So it will enter an infinite loop if we ask for 1. So we say 0. And as you can see, you get 20 values, 20 numbers that are between 1 and 5. And you have repeatance, okay? So let me show you that this will enter an infinite loop if we asked for like from 1 to 5. And we asked that each one is unique. So as you can see, it enters an infinite loop. So it will not finish. So let's go ahead and try some more examples. So give the size of the array. So let's say with, again, let's go 20. Okay, give the lowest value, let's say it's minus 10 to the power of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the highest value, let's say it is 10 to the power of, okay, 2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go 10, okay, to get bigger values. And unique values, no, there's no problem. So as you can see, all these values, if you check them, should be here. So if you check all of these values, they are going to be inside the ranges that we asked for. It's interesting that we got no negative value. So let's try this again. So let's try 100. From negative 100 to 100. Uniqueness. Okay, let's ask this to be unique, okay? So yes. Let's go ahead and have no unique values. So no unique values. Oh, I made a mistake. So the size of the array is going to be 100 again. Lowest value minus 100. Highest value 100. And no unique values, okay? So this is pretty much it. So this is pretty much how you do this. The only thing I would like to check is like for bigger sizes. So let's go ahead and say we have 100,000 numbers. So let's say 10,000 first, okay? 10,000 numbers, and the lowest value is minus 100,000, okay? And the highest value is 100,000, okay? And unique values, let's say unique values. So the time of execution of this program is actually something that has to do with how lucky we are, like how lucky that we are that our random generator will give unique values each time, okay? So here it goes, it runs, so you get the idea. Let's try greater sizes, so let's say 100,000 elements. The lowest value be minus 1 million, so 1, 2, 3, 4, 5, 6, and the highest value be 10 million. Okay, and unique. Okay, so you will see that it will take more time because you do not have that many numbers to pick from. That will always give you some array. Okay, so this will run. So let's stop this. So this essentially will give you the array. What is interesting to see is that if you ask like for 100 numbers, or like, yeah, for 100, let's go for 100, okay? And you say like you want from the lowest value to be 1, the highest value to be 100, okay? And you know if we want them to be unique, okay? So each time it runs to find that unique number. But if you have like more numbers, like let's say 100,000 again, okay? And you go from 1 to 100,000. So you have exactly how many values you will need. Like for the last value, you will calculate it until you get a different value. So let's say you want this to be unique, so yes. So as you can see, it takes more time. And the time it will take to execute might be infinite, okay? In this case, we are lucky and we get the list, like it already prints the list. Let's try this print without watching it. So as you can see, it is calculating this indeed. So that's pretty much it. That's pretty much how I would develop a random integer array generator, okay? Again, as I said, it's a Las Vegas solution. So if you are extremely unlucky, it might run forever, okay? So if I helped you guys, give a like to the video, subscribe to the channel, and the code will be in description, in a GitHub link, for you to use in whatever you want to do, test cases or whatever you want to do. So that's pretty much it, guys. See you in whatever I will be making next. Goodbye.